So this video lesson is all about exponents and powers. And it says intro to exponents and powers because really this is just a basic discussion of what is an exponent, what is a power, what are some ways that we use them, but there are many more ways that we'll end up using them, but those we're going to see in class. So this is just the basics. Before we get to exponents and powers, though, I want you to think first back to how did you learn multiplication? And not just how did you learn it, but what is multiplication actually? You didn't start by learning your facts, by memorizing your facts. It wasn't just 4 times 5 equals 20. You learned a process to take in and understand why 4 times 5 equals 20. If you want to stop the video here, or pause the video rather, think about that for a second and come back. You're welcome to. You can go ahead and do that now. Otherwise, we'll keep going here. When we talk about multiplication, what we really talk about when we start learning it is what's called repeated addition. That is, if we have 4 times 5, we learned that as 5 added to itself 4 times. Or perhaps 4 added to itself 5 times. So 4 plus 4 plus 4 plus 4 plus 4. So we learn it that way, and we start to understand that 5 added to itself 4 times and 4 added to itself 5 times give us the same answer called the product, and that this is what multiplication really is. So take a second, think 3 times 12. If you saw that, let's take a quick review. Pause the video, write out the 2 different addition facts that 3 times 12 really gives you. So on the one hand, the easier hand, 12 plus 12 plus 12. On the other, slightly longer hand, 3 added to itself 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So multiplication is just repeated addition. And a natural question that comes up after that is, if we can do it with multiplication, or we can do it with addition rather, can we have other repeated operations? Now, repeated subtraction is a little bit more difficult. That idea really doesn't exist at this point in math. But if we can do it with addition, perhaps we can do it with multiplication. For example, how would we represent that we want to multiply 4 by itself 3 times? So we're looking at something like 4 times 4 times 4. And how would we represent that, particularly if we're talking about repeated multiplication? And it turns out that this idea of repeated multiplication is exactly what we use powers for. So powers represent repeated multiplication. And a power looks like this. We have one number in blue, which is written normally, and is written sort of on the line that we normally write it on, and that's called the base. The number being multiplied is called the base. So in this case, we're multiplying 4 by itself some number of times. And we know how many times we're multiplying 4 by itself because we use this thing called the exponent, which is raised up above the first number. And the exponent tells us the number of times that the base 4 is being multiplied. Written up like this above the number is called being written in superscript. If it were written down below, it would be called subscript. But written above that number is called being written in superscript. And together, the base and the exponent form what's known as a power. A base and an exponent form what's called a power. So let's take a look at this particular power and understand what it means. Again, the base is the number being multiplied. So we're going to have some unknown number of 4s being multiplied by itself somewhere. How many? We're not sure yet until we look up at the exponent. And we find that this is 4 multiplied by itself 3 times. So in other words, 4 times 4 times 4. And we actually go through and multiply this out. 4 times 4 is 16, and 16 times 4 is 64. This is very, very different than what we understand as the regular multiplication that we've done, which is 4 times 3. 4 times 3 is 12. 12 is not the same as 64. 4 raised to the third power, or for this particular power, we call it 4 cubed, but 4 raised to the third power is 4 times 4 times 4, not 4 times 3. 4 multiplied 3 times, which gives you 64. So let's take a look at two different examples of that to make sure we've really got it. Then we'll give you some examples to practice with as we normally end the video lessons, and we will end it there. So these two examples, 5 to the second power, 4 to the fourth power. So it's important as we're listening to this and as you're hearing me speak that this is the way that we refer to powers. This is 5 to the second power, or 5 to the power of 2, or in this case, 5 squared because it's 2. And what that means is 5 multiplied by itself 2 times. Once here and twice here. 5 times 5 is 25. So 5 squared, not to be confused with 5 times 2, is 25. When we come into the next example here, 4 times 4, or not 4 times 4 rather, but 4 to the fourth power. There's no special name for a fourth power, it's just a fourth power. What that really means is we're taking 4 and we're multiplying it by itself 4 times. 4 times 4 times 4 times 4, which gives us 16 times 16, or 256. So 4 to the fourth power, 4 times 4 times 4 times 4, very different from 4 times 4, which is just 16, but 4 multiplied by itself 4 times is 256. So now let's go ahead. I'm going to give you 4 example problems to work on. Number 1, 5 as the base, 3 is the exponent. Number 2, 3 is the base, 5 is the exponent. Number 3, 2 is the base, 7 is the exponent. And number 4, 1 is the base, 15 is the exponent. So go ahead and pause the video. I want you to describe in words written down what each power means. That is, what number taken to what power, and evaluate. And evaluate just means do the actual multiplication through and find out a base of 5 with an exponent of 3 really means what number. So go ahead, pause the video, work on that, and then come back when you're done. All right, so let's start by looking at number 1 rather. Number 1 represents 5 to the third power. So we have 5 times 5 times 5, because the third power, of course, means that it's multiplied by itself 3 times. And so now we have 5 times 5 is 25. 25 times 5 gives us 125. And that is our answer. Number 2, 3 to the fifth power. And the reason I gave you this one next is to demonstrate that 5 to the third power and 3 to the fifth power are not actually the same thing, like 3 plus 5 and 5 plus 3, or 3 times 5 and 5 times 3. This is a whole new separate set of rules. 3 to the fifth is not the same as 5 to the third. So this is 3 to the fifth power. 3 times 3 times 3 times 3 times 3. 3 times 3 is 9, so this breaks down to 9 times 9 times 3, and 9 times 9 is 81. 81 times 3 is 243. So 3 to the fifth power is 243. 5 to the third power is 125. Very different answers, as I said. Number 3, we have 2 to the seventh power, 2 to the seventh power, which is 2 times 2 times 2 times 2 times 2 times 2 times 2. Multiply all this out, you get 4 times 4 times 4 times 2. 4 times 4 times 4, as we saw before. 4 to the third power is 64. 64 times 2 is 128. Make that 2 a little bit better. 128. And finally, 1 to the 15th power. 1 to the 15th power. I could write this out as 1 times 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 1. That was 15 ones. Or just recognize that 1 times itself is 1, and no matter how many times you do that, that is equal to 1. So I hope you wrote out 1 to the 15th power as 1 times 1 times 1, etc., because that's what I asked you to do, and as a practice for what the power actually means. But in practice, 1 to any power is 1. And so that leaves us with the question then, after all of this, of what else can we do with powers? Well, we've turned powers as they're written into the numbers that they actually evaluate into, and we can actually do that in reverse, which is something we'll be looking about in class, and we can do a number of other cool things with powers. But this is just the intro to get you started. Again, a power just refers to a base and an exponent, where the base is the number being multiplied, and the exponent times lets us know the number of times that the base is multiplied. Base, exponent.